Transition metal ions can bond to ligands to form complex ions with different shapes. Explain what is meant by the terms ligand, coordination number, and ligand substitution, using suitable examples of complex ions with different shapes, limited to monodentate ligands. Your answer should include diagrams and equations where appropriate.
So let's start by defining our terms. So the first term we need to define is a ligand. The definition of a ligand is that it will donate a lone pair of electrons to a metal ion, and this will form a dative covalent or coordinate bond with the metal ion. So we're told to use monodentate ligands in this question. That means that we're only going to donate one lone pair and form one dative covalent bond with the central metal ion. If this was bidentate, you would have two parts of your ligand that would form a dative covalent bond with your metal ion. So then we need to look at coordination number. Coordination number is the number of coordinate bonds to the metal ion. So the most common examples are octahedral, tetrahedral, and square planar, which we will look at in a bit more detail later on. And then finally, our last definition or last term that we need to define is ligand substitution. So ligand substitution is when one ligand replaces another. So a common side effect of this is something might start out as being octahedral, and then through ligand substitution it becomes tetrahedral, for example.
So now let's look at our complex ions with different shapes. So if we start by looking at complex ions with a coordination number of 6, an example is hexaaqua copper 2. So CuH2O6 and then 2+. So this is going to be octahedral if it's got a coordination number of 6. And we can show this in a 3D diagram where we have our central copper and then our octahedral arrangement shown using dashed and solid wedges. So it's important when you draw your ligands that the O is the one bonding to the copper and not the H or not the hydrogen, so it's the oxygen. Otherwise, it's not going to be correct because the lone pair that's donating to the copper to form this dative covalent bond is the oxygen and not the hydrogen. So here, if we just complete and we write out our H2O ligands, so these are monodentate ligands because only one part is forming this dative covalent bond, and then we need our big square brackets and our 2+ charge. So this is one example of a complex ion with an octahedral shape, but there are going to be multiple different shapes. So if we move on and look at something with a coordination number of 4, so if we start by looking at CuCl4 2-, keeping with the copper as the central metal ion. So this is going to be tetrahedral. So for clarity we can write tetrahedral, but we also need to show the 3D arrangement. So that's going to be Cu or copper in the middle, and then we have our wedges to signify it being a tetrahedral arrangement. And we don't need to worry about what part of the ligand is going to form the coordinate bond with copper because we've only got chlorine. So chlorine is going to be attached at each wedge, and we need to remember our 2- charge. But if you've got a coordination number of 4, you can also form a square planar configuration. So an example of a square planar configuration is anything in D8. So that could be, for example, PTNH3 brackets 2 Cl2. So this is platin and it can either be cis or trans. So we're going to draw both out now. So if we have platinum in the middle and we have our wedges to show the square planar arrangement, So we can either have the ligands being on opposite sides, making sure that the nitrogen of the ammonia is the one bonding to platinum. And so this would be trans because it's on opposite sides, so trans platin. But if you had them on the same side, that would be cisplatin, which we can now draw. So you can see that with a coordination number of 4, if it's D8, it won't form a tetrahedral arrangement. It will instead form this cis-trans square planar configuration. So here we've drawn the cisplatin. Now the last bit of the question is to show an example of ligand substitution. So looking at the examples we've given, we can show through ligand substitution how we go from octahedral to tetrahedral. So drawing out octahedral complex ion, that's CuH2O 6 2 plus 4Cl minus, and then that's going to form CuCl4 2 minus plus 6H2O. So the reason that we can only add 4 chlorines is because chlorine is such a big ligand, you can't fit more than 4 onto your copper. And you can see how the charges have balanced because you're going from 2 plus to 2 minus by adding 4 negative chlorines. Also, it's really important with ligand substitution to balance by writing the ligand that you've lost and how many you've lost. So here we've written 6H2O to show this. This is a level response question, which means to get the 6 marks, there aren't specific marking criteria. Instead, you need to have a comprehensive explanation of the terms ligand, coordination number, and ligand substitution, which we have at the beginning here. You must also have 3D diagrams of suitable examples of 6 and 4 coordinate complex ions with different shapes. So here we've got octahedral, tetrahedral, and square planar being coordination number of 4. And we also need to show ligand substitution illustrated with a balanced equation, which we have at the bottom, where we've shown how you can go from a complex ion with an octahedral shape to a complex ion with a tetrahedral shape through ligand substitution.